Okay, for the sake of another class. So this chapter I'm introducing cylindrical and spherical coordinate system. Now this chapter usually was an e-learning topic. That means students just do the e-learning themselves. Okay, but then I think we have extra time, so I say let's try to teach this topic 1 week. So before that, we have something called the rectangular coordinate system, which is actually this one. Okay, rectangular coordinate system we're very familiar. You got x and y and z, right? Coordinate axis, and usually the z-axis usually you follow the right hand rule. Okay, right hand rule. Turn the right hand from x to y axis, and you point the finger, top finger. That is the z-axis, and this is y. And this is all a rectangular coordinate system. Okay, pointed on the cross the right hand rule, right? So this, just in case you don't know what is the right hand rule, use the right hand. Okay, right hand, then cross the right hand, move from x-axis to y-axis, then the thumb, the point to the north, right? The point to the top, that is the right hand rule. You can list the x, y, z coordinate system are determined. Okay, this is the real x, y, z coordinate system. Okay. Of course, there is another system as in a game world. If you're playing game, then they use the left hand rule. Okay, left hand rule is the game world, so they can see the game system use different x, y, z coordinate system. So different. Okay, never mind. So I just for the physical world, then right hand rule for physical system. For if you use the left hand rule, then you point downwards. That is the game system, virtual system usually. Okay, then we know about this already. Then I'm going to talk about cylindrical coordinate system. So cylindrical coordinate system is this one, very similar to the polar coordinate. Right? Remember the polar coordinate system. So you have this r and theta. Okay, r and theta here. So this is r, the length. Okay, xy here. Just imagine that on a plane you have y, x, y here, and then the theta tell you people direction. So using this, we know that what is r now? R cosine theta is actually your x here. R sine theta is actually your y. Now they just put an additional z inside there. So z is still z. In the point x, y, z, now you get z is still z here. So this is polar, this is cylindrical coordinate system. So there's r theta z, extra z now for the third dimension. Okay, this is extra z for the third dimension. Okay, so they use the r, tell people how far away you're away from the z-axis. Okay, how far away from the z-axis, and then theta the direction, okay, from the x-axis, then z is how far up, okay, to the z coordinate. So this is cylindrical coordinate system. Okay, then I must talk about the next one is a spherical coordinate system. Okay, spherical coordinate system. So what is this spherical coordinate system here? So I think I can insert a new page here. Okay, and then I want to copy this one. Okay, let me copy this one. Okay, no space. So I want to copy this one. Okay. So this one, copy here, spherical coordinate system. Okay, now I explain to you. Okay, let me see the message. Any message? Then have two messages. I think. Anything? Okay, now alright. So we are not very late. Just introduction only. So okay. So another way to specify the point in space, right? So you have point in space, but this time I'm using this type of coordinate system now. Instead of x, y, z, r, theta, z, there's one called spherical coordinate. Okay, the one is it. So there is rho here. Rho, instead of distance from the z-axis, now this rho is a distance from origin. So how far away is this point from origin? Okay, instead of how far away from the z-axis where you have a cylindrical coordinate, now rho is the distance from origin. How far it is away from origin? Okay, you can see the point. And then the theta now, okay, direction now, angle, the direction from x-axis. So measure from x-axis, okay, tell direction, and so this angle theta can be 0 to 2 pi. Okay, we have said it, theta can be 0 from 2 pi. Okay, will not be equal. So I want to have 0 to pi not including 2 pi so that there is no confusion. So 0 means 0, 2 pi, but less 2 pi because 2 pi can be equal to 0, right? But it's the one that happened. So that's why this. The rho is the distance from origin, so of course rho is always greater than equal to 0. And then there's another angle, this one. Now this angle is angle measure down from z-axis. So you can see the diagram, measure down from x-axis, and this angle will be from 0 to pi. Okay, 0 to pi, okay, can be equal to pi. Okay, can be equal to pi here, 0 to pi. Okay, you can see that. So how come it's not 0 to pi now? Because depend on how you set the coordinate here. So I need not to go to 0 to 2 pi, otherwise you'll repeat the same point, right? So in this case, 0 all the way to pi, half here, right? So you don't need to go away to 2 pi because your theta can go to 0 to pi already. So theta is enough already. So this is called the spherical coordinate. Okay.
So the angle from the down from the z-axis, right? There's no negative angle, right?
There's no negative angle on 0 to pi.
Okay.
And don't need to go for beyond pi is 180, right?
Okay.
Then you can see actually say 190, but 190 is actually don't need to do that because actually it's controlled by theta now. Your theta, when you change your theta, you can get the same coordinate because 190 is actually opposite side now. Okay. Yeah.
Okay.
Okay, so this is about the spherical coordinate. Because I think cylindrical coordinate and rectangular coordinate are more familiar, right? Because it's not much different from polar coordinate. It's a spherical coordinate. How the way they measure, you see rho, theta, and the angle phi. Okay, so now let's look at some of the meaning of this thing. When rectangular coordinate, we know when the x equal x low, y equal y zero, and z equal 0, these are called coordinate plane. Okay, means x is a constant, y is constant, z is constant. What are they? So if we say x equal x low, this is actually a yz plane. Okay, parallel to yz plane. Okay, not necessarily parallel to yz plane. So parallel to yz plane is x equal x low. Okay, in parallel the xz plane, there you have y equal y0, this parallel xz plane, and then z equal z0 is parallel to xy plane. Okay, so if you want to see the picture, just draw a picture here. Okay, x, y, z here. So when you say you have a plane z equal z0 here, so this somewhere is z0 here, and you draw a plane passing through z equal z0 here. So this plane is parallel to xy plane. Xy plane is the plane below, right? Parallel to plane xy plane, parallel below. Okay, so what happens if you put a y equal z y0? So if I draw a picture here, so let's say I draw an angle one, x, y, z here. So y equal y0 is here. So you draw a plane parallel to y, parallel passing through y0. Okay, passing through y0. So this is this plane here passing through y0, right? So this plane is parallel to xz plane. So which is here. Okay. So if you want to say I draw a plane so that x equal x0. So let's say I draw a plane here. So x, y, z here. So x equal z, x0 is here. So you draw a plane, you'll find that pass through x0. This plane here parallel to z, yz plane. Then yz plane is one below. Okay, yz plane is the plane below, right? So these are the discussion of constant plane. Okay, so this one we are actually quite familiar already. Okay, it's just a different way to describe the plane. Okay, if we have plane x equal to constant, y equal to constant, z equal to constant, what kind of plane is that? Okay. Now, how about the next one? If you use the cylinder coordinate, okay, cylinder coordinate. So I may copy this one again to highlight to you. Okay, so I'm going on next page here. Okay, insert another page here. Okay, when we say R equal R0, what does it mean? So remember, R, this is cylinder coordinate, okay? So we get x-axis, x-axis, y-axis, z-axis. So what does the R mean? R is a distance measured from z-axis. So this is z-axis here. So measure from z-axis, what do we get if the distance is r0, fixed number? So we got this r0 here, means this is the distance here from z-axis r0. So what you get is actually a surface perpendicular, okay, a surface. Okay, this is actually a cylinder surface, right? So this is actually the surface. In this case, you got this surface, everything on the surface. Okay, let me, okay, everything on the surface. Distance r0 away. Okay, so what you get this is this one. what happens if theta equal theta 0, fixed number? So theta is measured, theta is an angle measured from the x-axis. So yeah, x-axis, y-axis, z-axis now. So theta suppose is here now. So what kind of surface is that? So this one is actually a plane now. If you draw a plane passing through the z-axis and here, so actually this is a plane. Everything on this plane is constant, where theta is equal to theta 0. Okay, and then finally z equal to z0, we already see something like this already. For z equal to z0, we see something like this. This is x, y, z. So z equal to z0, we draw. What does it mean? It means this is a horizontal plane. Okay, z equal to z0. So all these picture you can see on the next page here. Okay, this is okay, r x y z. Okay, this is a cylinder, y equal r0, and then the plane cut through the theta equal to theta 0, you get a plane, make an angle.
Right.
Yes.
What's the
Yes.
meaning of half plane? I don't get it.
Half plane, because theta equal to theta 0 is a half plane. Okay, why is half plane? Because if you look at this one, you're only looking at this one, half plane. Okay, why? Theta here. So you actually got this plane only. This angle is theta. This is half plane. The other half on the other side is not considered. This for theta equal to 0, theta 0.
Oh,
Okay, your theta can be if you go to another half, this is another angle now. Okay, so there's another angle, there's half plane. Okay, another angle now. So actually, if you go to another half, where is theta, it's actually 100 0 plus theta, then the on the other half. Okay, that's why you call half plane. Okay, half a plane. It doesn't go through the other side of z-axis. Okay, it doesn't go through the other side. If you want to go through z-axis there, then it's another plane now. Okay, half plane. That's why it doesn't go beyond, right? This one, it go beyond, that is another, sorry, it is. The angle is not theta 0, it's 100 0, 180 plus theta 0 now. Okay, so that's why it's half plane.
okay.
Yep. Okay, so that is on cylindrical coordinate. Then I want to talk about the spherical coordinate now, right? So, okay, let me show you. Okay, wait for a while. Okay, spherical coordinate. Okay, what happens when I have rho is rho 0, theta is theta 0, and phi is 0 now. Okay, this is a picture here. Okay, so what does means rho is equal to rho 0? This is actually mean the distance from the origin is rho 0. So what cause the origin here, x, y, z, the origin, distance from origin is rho. Okay, not the axis now. This distance from origin is rho. Of course, this is what? These are the point which is a sphere. So this is a sphere now. Okay, so rho equal rho 0 means this is a sphere now. Center of origin. Okay, all the point on the sphere. Okay, all the point on the sphere. Okay, at distance rho 0. Then got a sphere, right? So this is a sphere here. Okay, then how about the other one? Theta equal to theta 0 is the same as the cylindrical coordinate, right? Make an angle theta. with the z-axis, and you only half plane again. Okay, it's half plane again, right? Because the theta can be, if you want to get the other half on opposite side, it just the theta will be 180 plus theta 0. Okay. Finally, the last one, what happens if phi equal to phi 0? Okay, when you do that, what kind of object you get now? So, draw a picture for you. Okay, x, y, z. You want to go down, angle phi 0. So, what kind of object is that? All the angle must be phi 0. So, when you do that, you are going to get a cone. Everywhere, same angle here, every direction, same angle here, so go every direction here, and what you get is actually a cone. Okay, that's why from there you actually get a cone opening up. Okay, this is for phi is from 0 to pi. Okay, phi from 0 to pi. Sorry, phi from 0 to pi over 2. Okay, and this when p equals 0 actually is on the z-axis. When phi equal pi over 2, you actually got a circle. Okay, the whole plane already. Okay, so what is that? If this one is less than pi over 2, of course it's a cone. Okay, a cone opening up. Okay, if this is more than pi over 2 and less than pi, first it can be go to pi, right? Then this is opening down. Okay, because this angle can be more than 90 degrees, right? So, and what happens when it's at 90 degrees? Actually, the cone is a flat now. Okay, and this is the xy plane now. XY plane. Okay, so if this phi 0 is less than pi over 2, you have a cone. Okay, every point on the cone is given by that equation. So all this constant actually got meaning there. Right? So how to get the spherical coordinate? Okay, like that. Okay, so how do you convert them? Okay, define the different coordinate system. So between cylindrical and rectangular, very straightforward because you just convert x and y to r theta, and then z should be the same. Okay, so this is very straightforward. Your x and y convert to cylindrical, x and z, x and y convert r and theta using polar coordinate, and z the same. Okay, then the harder one is cylindrical and spherical coordinate. Is actually you have to do something because I think the slight differences are only the theta is the same. Okay, because for cylindrical and spherical, only theta is the same. Okay, so theta don't need to touch, but the rest you have to change. Okay? Theta don't need to touch. Okay? The rest you have to change. Okay, the relationship, okay, is actually quite straightforward. When you try to draw it, what happened to all the different conversion. And finally, the spherical, the rectangular, how do you do this? There are a bunch of formula for this, but usually people don't remember this formula. You just draw a diagram. Yes? Yep. But as a question, I think I have one question here. Let me see. Yeah. What is it you want to ask? Okay. So let me see who is here. So Philippine not here yet. Okay, wait for a while. Okay, I will show you because the formula actually quite straightforward one. Okay, once you draw a diagram, you can actually figure out yourself. Okay, anyway, this is not worry. Okay, when you do the quiz, you just refer to this too. Okay, so here is the explanation. Okay, this is figure out the XYZ and cylindrical coordinate. Okay, this part here, XYZ and cylindrical coordinate. So suppose you have a X. Okay, let's look at this one. This one is a more familiar one, right? So we know that how to convert r theta z. Okay, how to convert r theta z, r theta z into x y z there. Basically, you get x equal r cosine theta, y equal r sin theta, everything the same. Then you get r theta z become x y z really. Okay, how about the other way around? Okay, how to get, this is actually for r theta z to x y z, right? How about x y z? Okay, how about x y z to r theta z? Okay, what you can find, r is what now? R is a distance measured from z-axis, so r is equal to square root of x squared by y squared. Okay, if you have x and y there, you can see from the picture, r is actually this one, okay, which is x squared by y squared. Right? This is my angle here. And what is theta here? So you know tangent theta is y over x here. That's how I get theta here. And of course, you have to know what is x and y and which quadrant it belongs to before you get a theta. Okay, so z is still the same. They are actually the same z here. So your r, x and y, you can turn to r and theta. Okay, so get theta here, right? Get r, get theta. This same as a polar coordinate. Okay, so this is an easy one. We actually are quite familiar with them. Now, let's look at the other one. Okay, suppose you have spherical coordinate. So what is the spherical coordinate here? Spherical coordinate is actually here rho spherical. I want to convert spherical coordinate to x, y, z. Okay, so this one is actually rho theta phi. I want to get the x, y, z here. Okay, what is actually rho? Okay, so I think the next diagram is better because this diagram is not very helpful here. So I can show you the next diagram better here. Maybe I will use the right here first. Okay. So rho is the distance from the origin, right? So this distance here is rho. So how do you find x now? So if this angle is phi, okay, so that means that this distance, if we join from the z-axis, okay, z-axis here, so you join this from z-axis here 90 degree. Okay, let me, I want to draw it here. Okay, this is actually distance r here. Okay, because this is phi here. Okay, so this distance, because 90 degree, this is rho of sine theta. So this distance here, because opposite, right? Opposite our angle. So this is rho sine theta, which is actually the r here. Same as r, right? Rho sine theta is r. Then how to find the x now? Okay, so r cosine theta is x here. So that is why this one is your r here. R cosine theta is your x. Okay, same thing here. This is your r here. R sine theta is a y. Okay, then your z is actually r cosine theta now, because this adjacent or angle here, z equal to r cos. So this part here is r cosine theta now. This part here, same, z equal to r cosine theta. It's actually rho cosine theta, right? Rho okay, rho cosine phi. That's why you have this formula. It is same as the z here. That's why you can convert the rho theta phi into x, y, z in this way. Okay, so how about the other way now? Okay, so the other way is actually you have x, y, z. Okay, convert to rho theta phi. How to do that? So rho is actually distance from origin. So distance from origin is actually rho, which is square root of x squared plus y squared plus z squared. This is how you find rho. Then how to find the theta here? Theta is just the difference between the y. Okay, you can see a theta here. Theta, tangent theta is actually same as polar coordinate y over x. Okay, tangent theta get y over x. So we get theta now. After you know the quadrant of x and y. So you can find theta in this way. How to do phi here? So phi, how do you find? So phi is actually how do I find here? Can I find phi here? Phi is the angle between z and rho, right? Tangent theta, tangent phi, tangent, tangent. Okay, I don't want to use tangent. And we use sine opposite. Okay, let me try this sine here. So rho of z over rho, right? Z over rho is actually z over rho is actually, okay, I can spell it. Z over rho, rho is the distance from origin. Okay, z over rho is equal to z over rho is a cosine of phi. Okay, that means that z over square root of x squared plus y squared z squared is equal to cosine of phi. Okay, this is how you find the angle, rho, theta, and phi. So these are the picture, conversion picture, right? How to convert from cylindrical to rectangular, and then rectangular to cylindrical. And also I show you how to convert from spherical to XYZ. The other way is how from XYZ to spherical. Okay, I think the member actually just for diagram on it, you get all the things you want. Okay, so I can WhatsApp these pages to you. Okay, WhatsApp some pages to you because okay, I think okay, so I just okay, I start with this one, so nothing here. Okay, this one about as I explained already. So this one actually started to get interesting, so I can show you a picture here. And then this one started to show some make some sense. Okay, so this one also will show you some the picture. I think it's the same, don't need the notes there. Okay, so this one explain a bit of the spatial coordinate. Okay. Spatial coordinate here. And then the conversion is the part that is most messy here. But as I say, usually people don't remember this formula. Okay, I say just everything, draw a diagram and work out. Okay, you can draw a diagram and then work out. So this is some of the diagram to show you the relation. So I'm going to look at some example. So I didn't see anybody is here later now. Okay. So still Fabian is not here yet. Okay. So I continue. So example, okay. So example, first one, find the rectangular coordinate given a cylindrical coordinate. Right? So what we mean is r theta z now. So this r here, r is 4. So it's quite obvious here. So I have r equal 4 now. And this is actually pi over 3 is theta. And this is 4 is z here. So rectangular coordinate, how do you find? So that is quite easy. You just x equal to what? So x equal to first one, x equal to r cosine theta. Then you get x already. And then y equal to r sine theta. Z equal to 4. Same. And z equal to 3, sorry. Z equal to minus 3. And z is the same. Okay, so you can put in the information. Theta equal pi over 3, r equal 4, and then you can find out the point. So from cylindrical to rectangular is how. So you can see from where is the point now, okay? The point actually is trying to get it. Let's see r equal to 4. The distance away from the z-axis is 4. So you can find that, okay, this is how you point. Distance from z-axis is 4. Is this line? Because this is 4 now. So this line is z equal to 4. R equal to 4 now. Okay. R equal to 4. How far away? Okay. Theta pi over 3 show you the direction. Okay. The pi will show the direction. So actually on this plane now. And then say z equal to minus 3. So z equal to minus 3 is moved down to 3 units. Okay. So this is on the xy plane, so this distance is 3 units below xy plane. Okay, distance 3 units below xy plane. So a bit messy here, but if I clear out all these things, you can see clearer. Okay, the point is at -3, then z equal -3, and then where direction, okay, direction how far away from the z-axis. Okay, let's try to next one, example 1. I want to find the location of a point now. Rho is pi, what rho equal 4? So rho equal 4 is how far away from the origin? Okay, rho equal to 4, how far is it from origin? And then theta pi over 3, the direction, and then phi equal pi over 4. So where is this point now? So I will tell you, okay, rho is the distance from origin, so this is 4 here. Rho is 4, okay? Distance from origin. So from here, then you can find out, okay, if rho is equal to 4, rho is equal to 4 now, then what is this length now? So this length, the angle is pi over 4, right? Phi is pi over 4. So this length here is sine by rho sine pi over 4, okay? So this is actually, this length here is rho sine, okay, rho sine pi over 4 is 4 sine pi over 4. So actually 4 times square root 2 over 2 is 2 square root 2. Okay, then you find this is 2 square root 2, but that is not what you want because I want the x and y. So, but that is actually the r here, the usual one, r here. So this is actually the r here. Okay, so r cosine theta is x, right? Theta is pi over 3. That's why r cosine theta, this r here. R cosine theta pi over 3 here. That's why I get square root 2. Same thing, r sine theta is y. That's how I get y here. So this r here. R sine pi over 3, you get y. Then how about z there? So z is actually this distance here. Okay, z is this distance here. And z is this distance here, which is also this distance here. And this distance is actually rho of cosine pi over 4. Okay, rho of cosine pi over 4. So actually rho cosine pi over 4, where rho is 4 now. So that's why 4 cosine pi over 4. You get 2 square root 2. Okay, so you get an x, y, z now. And based on this, all the x, y, z come out. So this example 1. Okay, this one actually quite easy, right? Just geometry will do only. Geometry only. Okay, there's example 1.
Rachel, we have copy finish.
Yeah, okay.
Yeah, thank you.
Okay, so hopefully I have copy already.
Yeah, copy finish already. I
Okay,
copy the
thank you.
formula. Yeah.
Okay,
Yes.
to show you the comparison. So basically this chapter is quite easy. You just draw a diagram and then look at the relation between them. Okay, so I think I go to example 2. Okay, example 2 first. So example 2, find the spherical coordinate, and if you know x, y, z now. So x, y, z is 4 minus 4, 4 square root 6. This is x, y, z, right? Okay. I want the spherical coordinate. Spherical coordinate means what? Spherical coordinate is going rho, theta, phi. Okay, rho, theta, phi. Rho is the distance from the origin. Theta is measured from x-axis. Phi is measured downward from the z-axis. So the point is actually 4 minus 4, 4 square root 6. So where is 4 minus 4 square root 6? So I have a picture of x-axis. Let's draw an x-axis here. So let me show you here. This is the x-axis. Okay, this is the y-axis here. Okay, always x-axis, y-axis here. Okay, the right hand rule to cross the z-axis. Okay, usually use your right hand cross on z-axis, x-axis to y-axis. The thumb should be in z direction. Okay, so this is how we know that cross on x-axis to y-axis. So what is x coordinate? X coordinate is 4, right? So x coordinate is 4, so you can say this is 4 here, 4. So x coordinate is 4. So that means that go here, this line x equal to 4. Everything on this line is x equal to 4. Okay? Everything on this line x equal to 4 now. Okay, you go here, 4. And then y also 4. Okay? Y also 4. So sorry, y is minus 4. So y minus 4, what does it mean now? This is y equal to minus 4 here. Okay, y equal to minus 4. So from here, you actually got this plane now. So this plane is y equal to minus 4. So everything here, okay, everything here y equal to minus 4 now. So basically, what you get now, you have this point y equal to minus 4. So let's see y equal to minus 4 here. So from Okay, so x equal 4 this way, x equal 4 this way here, y equal 4 minus 4 this way. So get this point. Okay, so every point on here have x equal 4, y equal minus 4. Okay, then z equal 4 square root 6. Z equal 4 square root 6. How to get z equal 4 square root 6 here? So the point actually is here now. So I show you. I have a point. Every point here, this is the point x equal to 4, y equal to 4. Okay. X equal to 4, y minus 4, right? This is 0. Okay. So have to go up all the way to 4 square root 6. 4 square root 6 here. Okay, so how do you, you just all the way go up to 4 square root 6, then you got this point. Okay, so x equal to 4, y equal to minus 4, then z equal to 4 square root 6 here. So where is actually rho and theta and phi, right? So rho is very easy. Rho is a distance. Once you know x, y, z, okay, rho is actually the square root of x squared, 4 squared plus minus 4 squared plus 4 square root 6 squared. Take a square root, there will be a rho. So this one is 8 square root 2. And once you get it, so the distance from the origin is 8 square root 2. Then this is how to find a rho. Now theta is y over x, right? Theta is a tangent of y over x here. So how do you find your theta here? So y over x, so y is equal to minus 4, x equal to 4. Okay, y equal to 4, minus 4, x equal to 4, so get tangent theta equal to minus 1. Okay, tangent theta equal to minus 1. And so if tangent theta equal to minus 1, what is the angle here? So you can see from here, if actually from the diagram, okay, on the xy plane, right? So if you draw xy plane here, so you see here, x, y plane, right? You have 4 minus 4. 4 minus 4 is here. X equal to 4, y minus 4, right? So this is 4 minus 4. So point is here. So the angle theta is measured from the x-axis, right? So this angle there, theta. Okay. So where is angle here? You know this pi over 4. So the angle we measure from the x positive axis is 7 pi over 4, right? So that is why I get 7 pi over 4 here. Okay, 7 pi over 4. And then the phi here, how do you find phi here? So this is your z here. Okay, phi is this angle. Okay, phi is this angle here. So so we know that this is, okay, let me see, cosine phi here. Okay, cosine phi here is actually equal to 4 square root 6 over rho. Rho is 8 square root 6, right? 8 square root 2, right? Cosine phi is actually z over rho, right? So from there, you can find that this is actually square root 3 over 2. And you find that if this is the case, what is phi now? Phi is equal to pi over 6, right? Square root 3 over 2, there's a phi equal to pi over 6, you get this one. Z over. Okay, so this is actually how you sort out all this. How to sort out all this. Okay, so can I continue? Next one, example 3.
Wait, how is a circle theta? I don't get it.
Theta.
Yes.
Okay, you see the point x equal to 4, y equal to minus 4, right?
Yep.
X equal to 4, y equal to minus 4 is in the fourth quadrant, right?
Yep.
In the fourth quadrant, right? And you measure theta from the positive x-axis. So you measure the theta from here, okay, to all the way to here. Okay, and what is this theta now? It's 7 pi over 4, right? The above pi over 4 is 45 degrees. So this angle is 7 pi over 4. That's how we get this angle here. X, yeah, x equal to 4, y equal to minus 4, right? Now you look at the x and y axis here. Where is the angle now? Measure from the positive z-axis, positive x-axis, sorry. So you find the angle is 7 pi over 4. Okay, so after you got tangent theta equal minus 1 away, you have to figure out where is the point now in which quadrant it belongs to, then you write down the angle. Okay, so let me finish off the example 3. It's all right now. Okay, last example only. Okay. Example 3. Convert equation now. So suppose you have equation z equal to x squared by y squared. This is given in cylindrical coordinate now. This actually, sorry, this one is rectangular, right? I want cylindrical, spherical one. How to convert them? Okay, so conversion for the cylindrical is quite easy because r square is equal to x squared by y squared. Okay, so for cylindrical, you have a x, y, z here. So cylindrical quite easy here. Also theta here. So we have a x, y, z here. So you can find out. Okay, r square, this r here, r equal x square by y square. Okay, r equal x square by y square, right? So finish. This one quite easy. Okay, this x and y here. Okay, r equal x square by y square. How about into spherical coordinate? X square by y square is equal to, okay, what you do now? So remember the spherical coordinate now. So okay, now r is here. Okay, draw a better one. The cone here. Okay, so this is row here, and then this one, if you draw like cylindrical coordinate here, you copy this one, this r here. So r is equal to x square by y square, right? So this is actually, okay, what is actually z now? Z is actually this part here. This part is actually z cosine phi, right? Z equal rho cosine phi here. Okay, so this length here, this length here is same as this length here. Z cosine phi, right? So z is equal to rho cosine phi. Okay, that's why you got left hand side. Then right hand side. The right hand side is r here. X square by y square, r square, right? This r square here. But r is actually, this length here is actually rho sine phi. Okay, it's same as r here. So r square, we already know that r square is rho square sine square phi, right? Afterward, cancel one of the row here. So I will cancel get cosine phi rho sine square phi, right? So afterward, then you rewrite the equation, you get rho cosine phi divided by cosecant sine phi, you get cosecant square phi. Okay, divide this over, you got this equation. So example 3. So this finish off all the example for this chapter. Only left with tutorial only. So we'll take a break now. 8 o'clock we'll start the quiz, right? 8 o'clock we're gonna do the projectile quiz, okay? So take a break now.
Can you repeat why is it like p sine square again? Sorry, I wasn't listening.
Which one?
The cosine, don't know, the cosine 中 equals to p sine square 中, yes.
Okay.
Yes.
Cosine square. Okay, let me see. The cone here is here. Okay, first of all, I do a construction over here now. So what is actually z here? So the z coordinate, and z is actually the point here, right? Measure from the xy plane here, this z, right? So what is this z equal to? Okay. This is on the cone here, so I have a point z here. How do you find the z? Z is on how far is it away from the coordinate plane, and how far is it above the xy plane, right? So what is this system here? This system, okay, so you know that this is rho Okay, you know that this is rho here, and this angle is phi here. So this length here, the one I highlighted in green, now is actually rho cosine phi, right? And this is your z. So you have z here, but I don't need z. I need z is here now. Okay, z is okay, rho cosine phi. Using triangle. So you look at a triangle here, this rho here, and this long side is rho here, and this angle is phi here. Okay, so that answer B. So this is actually, you want to find the angle. What is this side now? It's a rho cosine phi. This side will be rho sine phi. Okay, the rho sine phi happen to be your R. So that is how the equation become like that. Okay, so you have this angle here, angle here. Okay, just like the usual triangle, it say this is A, this is theta here. When why is this one? This one maybe if this A here, this theta there, this A cosine theta, right? This A sine theta, right? The usual way to understand a triangle. Okay, so remember the triangle usual way. Polar coordinate, we have this thing. Usually when do this triangle, theta r, then this side will be r cosine theta. This side will be r sine theta. Okay, the similarity you can see from here. Okay, we will stop around and 8 o'clock.
Thank you.
Okay, 8 o'clock when we start the quiz, okay? Now after the quiz, you can do tutorial. Rest for a while. Okay, revise about your projectile motion. Then 8 o'clock we start quiz. Okay, stop recording.